All right, let's do a quick review first. Last Friday, we learned assignment operators. The equal sign, that's the regular assignment, and then plus equal sign, and minus equal sign, and multiplication, and division, and modulus, and so on. And it's a good way to make the code or the lines are short and concise, so you don't have to repeat the variable name when you do the math or assignment. And then we learned comparison operators is to compare two values. Of course, you can compare two variables or variable and a value or just two value, just to compare. And compare the actually the same type, I think. And the comparison operators are useful when used in the constitutional, in the conditions or in the test. Later on, we will learn more about those if, else, while, switch, and so on. So that's useful there. Then we learned Java scope. Two types of scopes. One is a method scope. Another one is block scope. So for method scope, a variable can be and can only be accessed inside that method and from the line where the variable is declared and to end of the method. And for block scope, the variable can only be accessed inside that block. The block, from the open curly brace to the closing curly brace. And the block is used when you use those conditional execution of code, like if something and then do something. That's normally use the curly braces to enclose a block of code. And the variable, if the variable is clear inside that block, then it can only be accessed inside that block. Okay. I hope you all try the quiz questions by yourself. Let's do it together. Let's see, what assignment operator used for? Oh, well, it's used for to assign value to variables. Well, do the math and then assign to the variables. What does that stand for? That stands for plus additional assignment. So in this case, if x is 10, then so plus equal 5, that means you add 5 to 10 and assign back to x. So that should be 15. And modulus is a similar thing. So you divide it. You divide the value by 3 and assign back. So that's should be 3, that's 9. So remainder is 1. So the x should be 1. What a comparison operator. That's to compare two values or variables. So if x is 10, is x equal to 10? No, that's false. Not equal to that, that's true. Yeah. 10 is not equal to 11, so that's true. If that 10 less or equal than 11, that's true. Yeah, 10 is less than 11, that's true. What is method scope? We just look at that. So variable defined in a method can only be accessed inside the method, and a variable defined in a block can only be accessed inside a block. So the answers are here. All right. So I don't recommend you to read the answer first, but always try to answer the questions and write down and then compare your answers with the answers given here, okay? And again, the recording, if you miss something or you want to do a review, you can always watch the lesson recording. Okay, today we are going to learn something new. First is logical operators. Logical operators are used to determine the logic between variables or values. So it's similar to the comparison, but it's not. The comparison is to compare two variables and values, right? So yeah, this is the comparison operators, agree that. But we are talking about the logical operators is to actually group the comparison together, you know. That's a comparison 1 and then comparison 2, and then group them together. And means both. If both true, then the whole thing is true. Okay, that's all they call the absent is called AND operator, and the vertical bar or double vertical bars, that's the OR operator. The OR means if either one is true, then the whole thing is true. Either one, either. If both are true, yeah, it's true. If either of the two is true, then the whole thing is true. There's exclamation as called a NOT operator. That means the reverse result. If this comparison is true, then the reverse is false. If the comparison is false, then reverse is true. So that's just, it's a NOT. It's just like, yeah. Let's see, almost like the minus sign, in math. If you minus something, if minus a positive value, then you got a negative value. If minus a negative value, then you get a positive value. So it's similar to that. Okay, let's try this example here. I do need a main function. Delete that. Yeah, we need that. I do need that. Let's make it easier. Okay. Boy. Shift. So let's say we have a variable int x equal to 50, and we declare a Boolean variable called b, and then we compare x with 30. So the first comparison is x greater than 30? I think the answer is yes, so it's true. Is x less than 100? Yeah, that's also true. So true and true. Then the result B should be true, right? Should be true. Let's see if we get that result. And compile the program. C. Oops. Java. Okay. Yeah, so the answer is true. You don't have to, you don't have to assign the compare this the result to a variable. You can always print out that directly. Let's say is x equal to 10, you ask, right? So the answer should be false. Yeah, so it's false. X is not equal to 10. So that's, you can either do that and rarely save that comprehensive variable, but normally actually for the logic operator is something like doing this. Again, they, use that in a condition, is x greater than 30. Here's a block of code. You print out something like out, say something, x is, well, something like let's assume x is age. You say, hey, he is older than 30. Let's assume that, yeah, the X stands for age. You can do that. Then, well, else if X greater than, well, yeah. Fine, yeah, let's say that, greater than 50. Oh, got an error here. Need a semicolon. So he's older than 50. Of course, if more than 50, that made the first one also. So we'll see what happens. I'll just do a final else. Whoops, what did I do? I said else. Well, not older than 30, not older than 50, they must be younger than 30. Or younger than, yeah, we'll see. Or is, younger or is, yeah, is younger or is. Younger than or is 30. If he is 30. Okay, semicolon. And let's see what we get. Compile. Clear my screen. Yeah, the false is from where? The false is from this line. Oh, never mind. So he is older than 30, yes. Yeah, because x 50 is greater than 30, not greater than 50, so you just meet that condition. So he's older than 30, so to meet the first one. If you change that to 30, see what happens. Oops. compile, run. He's younger than or is. Yeah, he is 30. Yeah, because he's 30. Yeah. So that means that meet this check because doesn't meet that, doesn't meet that test or condition, then it's else. This is a catch. This is the else is that's a catch all on this block. So we got this line. He's 30. That's how you use a comparison. And to demo the end, then yeah, actually, so, and he's greater than and less than or equal to 50. Then we print he's older than 30 and how about this younger than 51? Because so yeah, so 50 that's equal to 50 that's younger than 51. Then greater than 50. Yeah, no limit. That's okay. Yeah. So that's good. So I just want to demo you this end. Save that. Compile. There, that's, yeah, so that's 30. So make this first one. Even 50, we also get the first one because that's end there. Oh, well, even the first one to meet, that's the end. Yep. I print this one. Yes, 50 meet the first one. Okay, let's pick another one. Pick another example, the all thing. So then maybe add another variable. Well, let's see, 50, 40. So if x greater than so you can compare two variables. If both comparison are true, then it's true. So let's say at 40, they ask, okay, x greater than 30 and y greater than 100, then we print out the value. Well, it will print anyway, then it's true, otherwise false, right? So that's one way to, oh, well, I said we want to try all, so let's try all. Yeah, either or, right? In this case, either one is true, then it's true. So x is 50, that greater, so that's true. So that's true, then the result is true. You don't have even care about the second one. Only if the first one is false, then you want to check if the second one is true or false. That's the order actually. So let's see the first one false, second one false, so the result is false. Let's give a try. Yeah, we won't care about that one. Then we print the B, so that's a false there, right? That's all. So let's change that. Now we should get a true because the first one is false, but the second one is true. So we get a true. Yep, we get a true there. Okay. Oh, not. Delete this. Yeah, that's okay. Let's say, hey, let's add a not to it. Means reverse the value of b. You know, if the b is true, then reverse is false. If the b is false, then reverse should be true. Let's verify that. So we know that's true before the reverse. Now let's try with the reverse or not operator. Yeah, see now the true to false because we added this not operator. Okay, so you can use the not that way, or you can use this way. That's a syntax error. Yep. So to not, you can either not just the first part, just the first comparison. So this way, it will not just that part. The x greater than 30, yes, and not that's going to be a false. So we won't print this out with this not here. Let's test. See, instead we print the last line because, well, x is not greater than, but x equal to 50, x is 50 is true. We didn't print the first line because this part is true, but with a not, then that's false. So false and true is a false. So false and true equal to false. Oh, but I think we want, oh, that's a not operator, yes. Well, this is true. 50 greater than, so is a false. That means, well, is a not true equal to false. So the first part is this comparison itself is true, but with not true. So we got a false. False and true is still false. So that's one way to do it. That's why we didn't get that, then didn't get that. So we got that, the last string printed out. Then if you want to alter, you can alter the whole thing, then you can just move that to that. So not alter is alter the whole thing. Let's see, that's true. That's true. So true and true is true, but with a not, then it's a false. So that's still a false. Want to compile and test. So it's still false. However, if we change that, now the result is different because that's false. When one is false, then the whole thing is false. And when that's false and with a not, then it's true. So what we are having here is now is not false. So false, true, and the whole thing not. So because the false and the true is false, not false, so it's true now, right? And then we should print this line out. Let's test. Yeah, so we print this first line out because this condition, the whole thing is true. It's a little bit confusing initially, but when you get used to it, it's not that bad. Okay. Let me do it. Okay, 30 minutes. Let's move on to math. Yep, I think we got enough lot operators. Let's look at some math. In Java, Java math is a class. We will learn class later. And inside this class, there are many methods or math methods that allow us to perform mathematical tasks. There's a long list here. So if you want to see them, there might be more, might be more. This is like, a basic list. Just for example, ABS X, you get the absolute value of X. The X can be double, can be float, can be int, can be long. There's 8 edges. Let's see in the cosine, cosine, right? It's a cosine X, the X here is reading, not a degree, so it's a reading. It always a double value, the return is always double. Oh, most math functions or math methods return double value. See, the return type is double. This one is int. Yeah, this is return the exponent using that x. Well, that's an interesting function. I never use it, but that's an int. Why this one is? Oh, this is right. Of course, round means drop all the decimal digits. You just want to keep the integer part. That's why you return int. Let's see what else. Oh yeah, only 2 int, mostly just double. Okay. So sine, cosine, logarithm, and time-based. Max value, compare 2 values, get the max one or the higher one. And the mean, that means the minimum. You get the lower number between x and y, 2 numbers. Power off. Random, you get a random number. This sign, square root. Yeah, square root is useful. Oh, you even have the convert value from reading to degree or from degree to reading. How is the ULP? Return the size of a unit of least precision. Oh, never mind then. Not a common. Random function is common. Remember during the New Year celebration, we draw the we draw the random number of family IDs or student IDs for the prices. So we call the random function to return random numbers. So those are the math methods. If you need them and then forgot the syntax, you can always come to the method list table to look up. Let's just try a few of them. So the max is also when you call a method defined inside class, you can always call the start with the class name called a math dot and then the method name. So class dot method and the arguments or parameters you want to input. So let's see, we have x and y. We want to get the max value. You just call max.max and then x comma y. So that's very simple to use. Right. So you can pass two variables to it. Assume those variables are populated with value. If you don't give the value. I think that's an error. Let's see, we don't give the value and try to compare. See what happened. Oh yeah, so you don't even have to compile. You got this reminding. Say the local variable x may not have been initialized. It says, oh, fine, you define the variable, but you don't have a value. Initialize means assign a value to the variable. So the error is a warning, or error actually. It says the variable is not initialized or is not populated. Okay. Let me do a quick thing here until and okay. So then that basically you have to give the value. Yeah, now it's happy. I'll save it. Yep. So between those two, of course, 23 is higher. So the max that. If it's a minimum or lower, I don't know why it's called a lower. Between two, it's not more than two. So the lower of those, of course, is 10. And just confirm. Come on. Oh, there we go. Yeah, of course, it's 10. So that's the min and the max. Oh, square root. Yes, square root. Square root. Let's see. X is 100 and square root only take a one variable. Well, the little yellow tilde, yellow line here, just a little warning. The value of the local variable is not used. Fine. It's not an error. It's just since the color is yellow, it's just reminder. Basically, hey, you got a variable, but you don't use it. Why don't you just delete it to free some memory? Now it's fully happy. But even with that, you say, oh, don't mind, don't care, but it's still okay. It won't block you from compiling and run it. So, oh yeah, the math square, remember most of the math function return double. That's why we got a decimal points, the double value. So square root of 10 is 10. And of course, square root, let's see another one, 25. Who remember the square root of 25? Let's see, got the answer. Yeah, I think it's 5. Thank you. Let's see. Yep, it's 5. Okay, good. Let's see. Oh, yeah, absolute ABS, absolute value. So basically, it get the positive number of any number, negative, positive. It get the positive part. So that's absolute. Here, let's see, we got a negative value x, and the ABS should give us, oh, I wonder if the minus with a space, what happens? Let me try that. No, it's okay. I guess it doesn't matter with the multiple spaces. Yeah. I just want to make sure that minus is okay with some spaces from the number itself. Yeah, so yes. So X is a negative number, but with ABS, then we get the positive part, the positive value. Okay, that's ABS. Oh, another example I want to try is the random number. So the random function returns a value, a double value between 0.0 and 1.0, including 0.0, but not including 1. So get it? So it's any number from 0 to 1, but no 1. But it can return 0, but never return 1. So just a number smaller than 1, basically. All right. So what does that mean? X, why do we need an X there? We don't need an X. Yeah, I think let me see. Random? Yeah, no X, no. So this is, that's not, yeah. So that's not right. That's not required. So you don't have to pass any value to it to call it. You just call random and then empty, just like that. Just like that, okay? So, just delete that. And random, you don't have to pass anything to it. So we expect a number between 0 and 1. Okay. How about this? How about let's do a while loop. While we'll learn this later. Okay. While X greater than 0, do that. I hope it's okay. I hope. And well, in this case, X is not negative. Then negative is not greater than 0. So now change it to 25. So as long as the X is greater than 0, we print out a random number. And then here we have to change the X. Remember the minus, plus, plus? We do that. So this means, okay, X start with 25, print a random number. Then we take a 1 out of X, so that's 24. And come back and check, oh, 24 still greater than 0, and print out a random number, another random number. And then take another 1 from X. Now we got 23. 23 come back, still greater than 0, and call the random function again. So then the final effect is we would have 25 random numbers. Let's see if that works. Save it and compile. Clear my screen. Make the screen taller. Run it. Ooh, there we go. So, yeah, we got 25 random numbers between 0 and 1. Any zeros? No. Of course, no ones. But let's run the program. Keep running the program. Run again. Still no zeros. Yeah, it's since it's random and then so many digits, so it's really hard to hit a number you're thinking about. Okay, that's why it's random. It's really hard to catch. Yeah, well, there's someone close to 0, but it's not. So all the numbers around again. There we go. This is the highest number, 9, not a 1.1, of course, by design. Yeah, you got the idea, right? So that's the random numbers. Okay, yeah. Final thing is, since we have a couple minutes left, called recursion. Remember the recursion is non adjective is recursive, means iterative or looping. Recursive basically looping back, recursive. It's not different from loop. It's actually something, a function called the function itself. So you define a function, and inside the function you define functions here. Here is a function, right? You define function, but as part of the function definition, then you call the function itself. This is sometimes hard to understand because say, hey, you're defining a function, and then you call this function already. Isn't that too early to call it? Believe it or not, and in many programming languages, it's allowed. You can, you can let the function call the function itself. That'll create a recursion effect. Okay. So the definition of recursion is technique of making a function call itself. Sometimes it's a little bit difficult to understand. Of course, the best way to figure out is to try with examples. Let's see. Let's try. Remember, you add 2 numbers, right? You add a x, you add a y. You just call it add. It's easy. But if you ask to add a bunch of numbers, then maybe the recursion helps. So in this example is, we want to add all the numbers up to 10. Let's say we add a 1, add a 2, add a 3, and all the way up to 10. Then you can write a small recursive function called that. Okay. Yeah. That's a recursive function. Oh, that has to be outside the main function. Yeah, this is the main function, so we cannot put there. So we need to put outside. So we define a function called a sum. We give a parameter k. If the k is greater than 0, let's say k is a 1. We add a 1. It's a 1, then yeah, 1 is 0. So then that's a 1 plus, and then call the function again. The 1, take 1 out. The next smaller one is well, actually start with, yeah, the 1, that's 1 minus 1, 0, then 0, then that stopped. So normally you start the k with 10 actually. So let's see, how do we call it? This one is a little bit hard to understand, but so you may want to read this example multiple times. So we have this function, sum function. We give a value 10, start with 10, just call it once. Start with 10. So then you got a 10. And 10 is greater than 10, so return 10 plus sum 9. So I call back 9. 9 return 9 plus 8. some 8. So they keep going back, going back, going back. Then eventually you get the result, right? You call once, it loop 10 times, and then come back. Let's see what happens. Compile. Oh, come on. Something happened here. Oh, there we go. So that's a 55. You can verify that value. So what happened is you call the initial call is 10. So 10 plus some 9. And that next level, all that is equivalent to 10 plus 9 plus some 8. And then some 8 that return 8 plus some 7, and so on all the way to 0. So 0 is 0. So that's how it works. Maybe we can have more examples next time. So today we are running out of time. You may want to review this example after the class. Okay. All right, then. Do you have any questions? If not, then I see you next Friday. I think no class. Okay, no class next Friday. All right then.